Hello, today we're going to do another method for factoring trinomials. So far, all of the trinomials that we have factored have had a leading coefficient of 1, meaning in front of the x squared, we didn't have any number. We understood it to be a 1, but nothing larger. Today we're going to look at how to factor trinomials when the leading coefficient is not a 1. So this process is kind of similar, a little bit different. When you start to factor a trinomial where the leading coefficient is not a 1, you still want to make sure your trinomial is in standard form. So we still want descending order, squared term, plain old term, and then the constant. Then we're going to multiply the first number times the last number. So when you look at a trinomial, we typically write them in general as ax squared plus bx plus c. So we're going to multiply a times c, the first number times the last number. Then we're going to find the factors of a times c that add up to b, that add to the middle term. Use those to rewrite the middle term. And then since we'll have 4 things, we'll use factor by grouping, which we learned before. As always, when we factor our trinomials, we can always FOIL our answer to check it and see if we get back to the original question. When you take a look at the examples, it says factor a trinomial if it's possible. If the trinomial cannot be factored, write prime. So there are actually some cases where we can't factor, and I'll show you that when we get to one of them. So let's go through this process. So when I have a trinomial where the leading coefficient is not a 1, so here our leading coefficient is 3, definitely not a 1. We're going to start by multiplying our first and last terms. Multiply a times c. So here, 3 times 4, or a times c, makes 12. We now need the factors of 12 that add to the middle number, that add up to 8. So this part's similar to what you did before. So now I'd think of the factors of 12 that might add up to 8. So factors of 12, 1 and 12, 2 and 6, 3 and 4. And of those options, 2 and 6 will add to 8. Instead of going directly to factoring, we're going to use those two numbers, 2 and 6, to rewrite the middle term. So I still have my 3a squared, but now instead of 8a, I'm going to rewrite it as plus 6a plus 2a, and then plus 4. So these factors told me how to rewrite the middle term. I broke 8a into 6a's and 2a's. That's really the only new part of today's lesson. The rest of the factoring that I'm about to do, is factor by grouping, which we've learned before. So now if I factor by grouping, I look at just the first 2 terms, factor out their GCF. So here the GCF is 3a. If I factor out or divide out that 3a, I'm left with a plus 2. In the second set, the GCF is a 2, so I put my plus 2. When I divide out or factor out the 2 for the second group, I also get a plus 2. Remember, you have to have the same 2 parentheses when you factor by grouping. If you don't, there's some kind of a problem. Now I take out that common a plus 2, and if I factor out that common parenthesis from each big term, I'm left with 3a plus 2. Okay, this is our final answer. This is the factored form. Take a look at question number 2. So in question number 2, we have our trinomial. The leading coefficient, again, is not a 1. So we're going to start by multiplying our first term times our last term, A times C. So here, A times C is 2 times 7, or 14. I list the factors of 14, so 1 times 14, and 2 times 7. This one is a short list. And then I need to find the factors that add up to the middle term. So they have to add up to negative 11. No matter how hard I try, I can't get 1 and 14 or 2 and 7 to add up to negative 11. There are no numbers that multiply to 14 and add to negative 11. So this trinomial is prime. I can't factor this one or break it down into smaller parts. Okay, question number 3. Again, we have our trinomial. It's in descending order. The leading coefficient is not a 1, so I start by multiplying first term times last. When I multiply A times C, 2 times 20 is 40. I can list the factors of 40. So 1 times 40, 2 times 20, 4 times 10, 5 times 8. Then I look for a pair that adds to the middle number. So I need 2 factors that add to 13. Those 2 factors will be 5 and 8. Okay, then use those 2 factors to rewrite the middle term. So 2x squared stays the same, but 13x gets split up into 2 parts, 8x and 5x, both of them positive. So plus 8x plus 5x, and then recopy that plus 20. Now we do our factor by grouping. So if I look at the first 2 terms, the GCF here is 2x. So if I factor out a 2x from each of those terms, I'm left with x plus 4. In the second set of parentheses, the GCF is a positive 5. When I factor out positive 5 from each term, I get, again, x plus 4. That's a good sign. They have to be the same. I factor out that common parenthesis, x plus 4, and put the leftovers, 2x plus 5, in another set of parentheses. This is the factored form. And for the last example today, again, we have our trinomial descending order. Leading coefficient is not a 1, so we have to use this longer method of multiplying A times C. So here I have 4 times negative 35. I should highlight that with it. So when I multiply first times last, 4 times negative 35 is negative 140. I can list the factors of 140. So 1 times 140, 2 times 70, 4 times 35, 5 times 28, 7 times 20, and 10 times 14. From that list, I need to figure out which 2 factors I can get to add up to negative 4. So I have to play with the signs a little bit here, but 10 and 14 can give me negative 4 if I make the 14 negative. So I then take my factors and I use them to rewrite the middle term. So negative 4n gets broken into positive 10n and positive 14n. Everything else just gets copied down. Okay, then I do my factor by grouping now that I have 4 terms. So when I factor by grouping for the first 2 terms, the GCF is 2n. When I divide out or factor out that 2n, I'm left with 2n plus 5. In the second group, the GCF is 7. So if I factor out that positive 7, I'm left with 2n minus 5. And I just caught a mistake that I made. 14 should be negative. So here, this 14 should be a minus. So I'm actually going to factor out a negative 7. And when I factor out a negative 7, my 2 parentheses are in fact the same. Okay, now I factor out that common parenthesis of 2n plus 5. And my leftovers, once I do that, are 2n minus 7. This is our factored answer. Please make sure that you complete the homework problems below. If you have questions, post them on the comments section